is Dr. Esther Trufan, and in this video, I'm going to demonstrate the synthesis reaction that occurs between copper 2-sulfate pentahydrate and concentrated ammonia to produce tetramine copper 2 sulfate. For this experiment, we're going to need quite a bit of equipment because it has several steps. So the first thing we need to do is measure out some copper 2-sulfate pentahydrate, so we will need a scale. And because we are going to measure out the copper 2-sulfate pentahydrate from its original container, we need a secondary container so that we don't put our spatula inside the original container. Next, we need to do some prepping here because a lot of our washing solutions and washing liquids have to be chilled. So first, we're going to need some ethanol and some test tubes. Here I have 3 test tubes, some ethanol. I'm going to need a graduated cylinder to know the exact volume of ethanol I'm working with. I will need to know the exact volume of concentrated ammonia solution I'm working with, so I will use an additional graduated cylinder for that. If you have one graduated cylinder, simply between measurements, clean and dry your graduated cylinders. I will need my concentrated ammonia solution. I will also need some deionized water to make the copper sulfate solution. Then I will do a Buchner filtration, and I will need all the equipment that goes with it. That includes a Buchner funnel, a Buchner flask, a rubber hose that connects to the vacuum line, and very importantly, filter paper. And then we need some secondary containers to make sure that we are not reaching in any of these original containers. And then to get the exact amount of solutions, we may need to utilize some pipettes with their associated bulbs. Now that we have everything that we need, let's get started. The first thing we're going to do is set up our washing solutions that need to cool. And we begin our work with ethanol. We transfer some ethanol into one of our small beakers. And then using our graduated cylinder, we're going to first measure out 5 milliliters of ethanol. This does not have to be a very exact measurement, but if we can keep it close to approximately 5 milliliters, that's ideal. In my case, it is 5.13 milliliters. I will take one of my test tubes and transfer the ethanol into it. Once completed, I will transfer this into an ice bath. I will come back to that at the end, but for now, I don't quite need it. Next, I am going to measure out approximately 15 milliliters of ethanol into a second test tube. This one is 9.97 milliliters. And if I'm a little bit under, that's okay too. I have 2.78 milliliters in this one. This second ethanol amount will be used exclusively for washing, but it needs to be cold for that application. So I slide that too into the ice bath. Next, I will work on my third test tube, in which first I'm going to put 1.5 grams of the copper 2-sulfate pentahydrate. I need to start by turning on the scale, transferring a small amount of the copper 2-sulfate pentahydrate in a secondary container. It doesn't need to be much. I can always add a little bit more. Put a weighing boat on top of the scale, tare it, and then add 1.5 grams. Once I am done with this measurement, I can set the copper 2-sulfate pentahydrate to the side. I will take my measurement and then transfer all the copper 2-sulfate pentahydrate inside the third test tube. When it's done, for a while, I can set my scale to the side. Next, I need to measure out 4 milliliters of deionized water. It is important to not exceed the 4 milliliters because if we add more water, we're going to influence the solubility of the final complex if we have more water than intended in the final mixture. I have 3.95 milliliters of deionized water in my graduated cylinder. So I will transfer this inside my third test tube. And I can put my deionized water to the side. Before we move any further with this experiment, it is very important that we completely dissolve all the copper 2 sulfate pentahydrate. Now, it will be difficult to do that at room temperature. But there are a couple ways in which we can help it. We can do a lot of swooshing around, but that will only get us tired. The best solution to get this to fully dissolve is to use a warm or a hot water bath. The hotter it is, the less you have to keep it in there and the faster you achieve dissolution. So I prepared a hot water bath for me, and I will place my copper 2 sulfate pentahydrate solution in there. I will check in with it once in a while. This shouldn't take very long. In the meantime, we can move on to the next step, which is measuring out 2 milliliters of the concentrated ammonia solution. And this is the part where when you open the concentrated ammonia container, you will realize why I am doing this experiment in the fume hood and why you should do it too. If your hands are not very steady, feel free to use a pipette to measure out the 2 milliliters of concentrated ammonia. My copper salt is almost completely dissolved, but I will keep it there for just a little bit to make sure that it is 100% dissolved. In the meantime, now that I measured out the ammonia solution, I can put the ammonia to the side. The copper 2 sulfate pentahydrate is fully dissolved, and I can tell that because my solution is clear and there is no solid residue on the bottom. With that, I am done with my hot water bath and I can set it aside. Next, I am going to add the 2 milliliters of concentrated ammonia solution to my test tube 3 that contains the copper 2 sulfate solution. There's quite an instant color change. And for now, I am going to set my test tube to the side while I prepare for the next step. I will take a clean and empty small 50 milliliter beaker in which I'm going to take my 5 milliliters of cold ethanol and pour it over. And then we're done. And we can set that aside. Next, I'm going to take my reaction mixture here and pour it over into the ethanol. There's already precipitation happening, and if I look at the bottom of my beaker, I can see the formation of a blue solid. Next, it's a matter of transferring everything that we have here over into our beaker with additional washes of small increments of ethanol. We're going to take our larger amount of ethanol and add small increments of 2 to 3 milliliters each. With every addition, we're going to shake it thoroughly. And if the solid residue isn't letting go, we can always bring in the spatula and scrape it a little bit. We should use either a clean spatula or the side that we haven't used for measuring out the copper to sulfate pentahydrate. Once we are done scraping, we transfer everything fairly quickly and we do the rinsing at least one more time. This transfer step could be one of the reasons why our yield is not 100%. But we should make a strong conscientious effort to transfer as much of our solid as possible to the beaker. And with that, we are done with our test tubes, and our reaction mixture is now all inside the beaker. And even from the side, we can tell that there is quite a bit of solid formation. We may let our solid settle a little bit longer, or we may move ahead and do our filtration. For our Buchner filtration, once we have our Buchner flask and Buchner funnel, we need to find a suitably sized filter paper so that when we put it inside the funnel, it covers all the holes. If it doesn't do that, then we need to find a larger one and then use a pair of scissors to cut it to the right size. Once we're done with this, then we take our rubber hose and we connect it to the vacuum line. We will connect it to the Buchner flask in just a little bit. But first, we need to make sure that the filter paper will stick to the funnel. And so we're going to add just a couple drops of our solution on top of the filter paper. It will create a wet filter paper that will stick to the flask. And when we apply suction to it, it will pull it in and it will create a seal. So everything that goes through the funnel will also go through the paper, and the paper will keep all the particles that are larger than its pores on the top. Now that we are ready, we need our solution, and we're going to need the ethanol that we set aside for washing purposes. So let's get started with the filtration. First, we turn on the vacuum line. We connect it to the flask, and now it applies suction to it. Then we swirl our mixture so that we pick up as much of the solid as we can from the bottom and the side of the beaker. And then we transfer it all pretty quickly into the Buchner funnel. When we're done, if not everything transferred, we should scrape it with the spatula so it loosens up a little bit. Then we add a small amount of ethanol. Swirl it thoroughly and transfer it over. If not all of it transferred, we do it again. And we can do it one more time. Just as in previous instances, we're learning that transfers are rarely 100% effective. We do it one more time. And with that, we are considering our transfer complete, and we are mindful that we have lost some of our material. Then we're going to check on our filter paper, and we're going to see that the solid is drying out quite rapidly. We can disconnect for just a second. And then we can test to see whether our solid is indeed dry. If we scratch it a little bit with a spatula and it becomes powdery very quickly, then it means it's getting quite dry. There are still bits that are a little wet and muddy, so that means we can do two things. add a little bit more ethanol to wash away any residue or traces of water. And the other thing, we can just connect it to the vacuum line for a little bit longer. I have some leftover cold ethanol, so I'm going to use both methods. One way to tell that all our liquid passed through or all the solution passed through is that the bottom of the funnel is not releasing any more droplets. At that point, even if there is a little bit of wetness in there, it's just a matter of time until our solid is completely dry. And when I scrape my solid, it gets powdery really quick. So this is a good sign that I dried my powder as much as I could, and it is okay for me to disconnect from the vacuum line. For the next part, I'm going to extract my filter paper from the funnel, place it on a watch glass, and then prepare to collect the mass of my product. Once I extracted all the solid that I could, again, I recognize that some of it may have been lost in the process. For the final part, we need to record the mass of our product. So we will need to bring back our scale and a new weighing boat. Next, we remove the lid from the scale, turn it on, place a weighing boat on top of it, tare it, and then transfer as much of the solid from the watch glass and the filter paper as we can. Gentle scraping of the filter paper is okay. Harsh scraping isn't, because we don't want any cellulose fibers to be counted towards the mass of the product. The filter paper will be contaminated at this point, and it will always go into the solid waste bin. The final mass of my collected product is 1.37 grams. If we know the amount of copper 2 sulfate pentahydrate that we started with, and we know the mass of the product that we collected, we should have all the information to determine what is the percent yield of this synthesis reaction.